All right, so we're looking at the nutrition study from the data sets here, and I'm gonna go jump into the description. And reminder, if you need to search a big document like this, Control F on your keyboard or Command F if you're a Mac user, and then just type what you're looking for, nutrition study, and then hit enter a couple of times. It'll jump you down to where it is in the document. All right, so I found nutrition study here. Let's blow it up so we can read it better. All right, variables related to nutrition and health, 315 individuals. The individuals are the cases. Okay, so what's an individual here? So we're gonna have to look further down. So again, 315 observation, 17 different variables. All right, data from a cross-sectional study to investigate the relationship between personal characteristics and dietary factors and plasma concentration of retinol, beta carotene, and other carotenoids. Study subjects were patients who had an elective surgical procedure during a 3-year period to biopsy or remove a lesion of the lung, colon, breast, skin, ovary, or uterus that was found to be non-cancerous. Okay. Wow, that's a lot to take in. So I'm thinking here, all right, they're trying to describe what they were doing, what their sample was. They don't talk about how they got the sample. That's okay. If we went and read their document, notice they have a link down on the source there. There's probably more information, which sometimes I have to go look at that because I'm still like, what? What are they doing here? All right, so the sample was 315 people. Those people were patients who had an elective procedure. That elective surgical procedure was to biopsy or remove something from a certain part of the body. And that was found to be non-cancerous. Okay. All right, I kind of sort of maybe get the sample here. Looking down at the source below, it says determinants of plasma levels of beta carotene and retinol. Doesn't help me very much. I'm not a nurse or a doctor. So I'm going to click the link down here and see if I get a little more information maybe. All right, observational studies. Okay, so there wasn't an experiment. It was an observational study. Good to know. Observational studies have suggested low dietary intake or low plasma concentrations of retinol, beta carotene, or other carotenoids might be associated with the risk of developing certain types of cancer. So I'm trying to think now, what was their target population? Who are they interested in learning about? Now you might say it's only those 315 patients, but no, they're interested in a more general population. What might that population be? So I might broadly say all humans on Earth, right? Doctors live and work to help people be well. So it might be, okay, all people. That's possible. That's pretty big. Yeah, so yeah, they're definitely, we're looking at what kinds of predictors like your diet and certain, let's see, beta carotene, that's a type of vitamin. Is that right? Maybe. I'm not a nurse or doctor, I'm not exactly sure, but I've heard those words before. Yeah, so what kind of things in a person's life, it looks like mainly diet, are related to getting cancer. And can anyone get cancer? Yeah, kids get cancer, adults get cancer, teenagers get cancer, old people, everyone gets cancer. It's more common in older people, right? But everyone gets cancer. So I think I'm gonna have to say the population is just all human beings here. They're trying to learn about how to help people not get cancer by looking at diet. Now, you might say the sample might be a little biased because they're only looking at people who had a surgical procedure, and the result of that surgical procedure showed that the growth that they had was non-cancerous. Okay, so is it a representative sample of all humans? Not exactly, no, I don't think so. Okay, is it still a meaningful study? it gives us some ideas that, hey, maybe if you had more fiber in your diet, you might not get colon cancer or uterine cancer or breast cancer or something like that. And then they also look at these carotenoids. So let's make a couple notes about this nutrition study. There's my notebook here. All right. So we've got the nutrition study. And I'm just going to write down what I think the sample is based on, what they told me. And I think that's pretty straightforward. The sample is 315 people who had an elective surgical procedure, I think was the phrase they use. And, I need to look back at that description to be sure, but I'm pretty sure that's what it said. An elective surgical procedure. And I'm just going to summarize. They listed a whole bunch of things. I'm just going to say that involved removing a non-cancerous growth. Does that seem like a reasonable summary? I don't want to rewrite what they said, right? That's plagiarism. I just want to put it in my own words. And I'm usually thinking about my mom. What would my mom understand about this, right? So I want to keep it brief. So let's see. Who had an elective surgical procedure where a non-cancerous growth was biopsied or removed. And I don't remember how to spell biopsy, so let's take a look. I'll be back here. Oh, I guess it would just be, all right, it's not too hard. Biopsied or removed. Right, that's the sample. My guess from looking at the second description is they're really looking at a population of all humans. And unless they specifically say our target population was, it's always a guess on our part as the reader. So I believe that the population of interest is all humans, all people. And since they didn't specifically state it, it's debatable. Some people might say, hey, it's only people who might get cancer. What does that mean? I might get cancer, you might get cancer, right? My stepdad had cancer, he survived. My aunt had cancer and she didn't survive, right? So again, my point is sometimes it's hard to identify exactly what we're talking about because it wasn't necessarily clear in the report. But anytime I see data in the news, I'm thinking, where'd they get the data? Who are they talking about here? Am I in this group? Who is in this group? Who's not in this group? What's the population they're talking about? All right, next, what's a case here? Well, I think we pretty clearly state in our sample and description here, a case is a person, right? I'm just going to make a note of that for myself. Each case is a person. There's lots of different variables here. So I'm just going to pick on the variable called fat. Because over my lifetime, when I was young, I was told, well, you shouldn't have too much fat. That's bad for you. Now they're saying there's lots of good fat. You should have it. And then there's these keto diets people are taking, which is lots of meat and fat. And it's like, okay, what's going on here? Right. So fat is something that has interested me for years. And I don't know if you have noticed, I'm kind of a skinny guy. I don't have much fat. I always wanted to be bigger than I was. Other people want to be smaller than they are, right? The grass is always greener on the other side. And it doesn't matter how much fat I eat, unfortunately. I have this strange body type that I'm just stuck being skinny. But fat, I think, is interesting. And the question is, what does the variable fat mean? Let's look back at the description. I don't know. Grams of fat consumed per day. Okay, grams of fat. That's pretty straightforward. Cool, not too bad. And sometimes I read the definitions of the variables and I'm like, what? I still don't get it. And I got to do more research sometimes, but I think I get that. Okay, so grams of fat consumed per day. And what kind of variable is this? Quantitative or categorical? Quantitative, yeah, it's a number, right? Grams, it's something we can measure. I can throw that on a scale and say, hey, this is how much fat you had today. Really? How would I throw fat on a scale? Okay, how they got the grams of fat per day, that's a whole nother issue. But they had some kind of way to figure that out. There are lots of other variables here, like age. Blow that up again. Age is quantitative, right? It's a number. Smoked, it's a code for yes or no. Let's look at the data. Smoked prior is a 2 or a 1. Because that's a number, does that make it quantitative? No, they're just using those numbers to put people in a category, right? So let's see, what does it mean? Oh, wait a minute. There's two variables. There's smoke here and there's prior smoke there. Okay, I'm confused. Oh, prior smoke, okay. Smoking status. Okay, so smoker was coded as yes or no. I'm assuming that's like, are they a current smoker? So I'm looking at this here. Versus prior smoke, smoking status. Status is usually something that's current. Oh, yeah, there it says current. Okay, that's starting to make sense. They used to smoke, they never smoked, they're a current smoker. All right. So I'm assuming when they ask this question about a smoker, that would mean, do you smoke now or have you ever smoked? And then there's further categories down here that say never smoked, used to smoke, formerly smoked, or yeah, I currently smoke. All right. So that prior smoke is categories, it's categorical. Vitamin use, occasional, no, regular. Categorical or quantitative? Categorical, yeah, they're just putting people in a category. Do you take vitamins or not? Yeah, sometimes, all the time. No, I don't take vitamins. Sex versus gender, you know, those two terms are used interchangeably often. Is either male or female. They didn't have another option. And mostly we just have quantitative variables here. So we're going to look at the fat one. So let's look at the fat one. We're going to do things a little different today. We have it in a spreadsheet now. We'll come back and look at spreadsheet techniques in a minute. I want to look at the app called StatKey, which is an online statistics app that comes with our book. So what we're going to do is we're going to take the fat column and I'm going to copy that. And I'm going to go to a new sheet and I'm going to paste it in. Let's see, this file needs to be, oh shit, I forgot to make a copy. Make a copy for Gary. So we'll call this Gary's nutrition study. And I'm going to put it in a different place so as not to confuse it with other stuff. Let's put it in my 2022 notes section. Okay. All right. So hopefully you guys made a copy of this. And let me catch up to you there. All right. So I only want to look at fat. So I'm just going to put that on another tab by copying it, pasting it. Okay. There we go. Thank you. All right. So there it is. So next I want to get that in the StatKey. Now, the format of the data matters in StatKey. And usually if you copy a column from a spreadsheet, it'll work in StatKey. So let's go over to StatKey. So back to useful websites. And there's a link to StatKey here on the useful websites page in Canvas. All right, so then in StatKey, they have all of these different links for different statistical tools. And I just have to look at the description and figure out, well, what am I doing here? So I'm doing descriptive statistics right now with you. So that would be the first column. And in the first column, they describe different kinds of variables. One quantitative, one categorical, one quantitative and one categorical, two categoricals or two quantitative variables. And we have one quantitative variable right now. So we're just going to go to that first link. Okay, StatKey interface here. I'm going to blow this up just a little bit. It comes with a whole bunch of data. They just loaded a data set for me called mammal longevity up here in the upper left. And there's a whole bunch of other ones. The fat data from the nutrition study isn't one of them. So my usual procedure for putting my own data in there is to edit their data. It's easier than uploading a file in most cases. So we're going to go to edit data. And anytime you go to the edit data in StatKey, you want to read what it says here and think about, does the data you're copying fit how they want it? So this data came in, the mammal longevity, as animal, longevity, and then it says baboon 20, black bear 18, and there's a comma in between them. So if I wanted data kind of like this, I might need each person's name with their fat or maybe their gender or something, but I didn't copy that, okay? Notice down underneath that block of numbers and words, it says checkbox, first column identifier, right? So they're identifying the number 20 as going with the baboon and the number 18 is going with the black bear. We don't have a column of identifiers for each of our fat numbers, do we? So we're just gonna uncheck that box. I'll go to the header row in a minute. I just want to delete all their data, highlight it, delete it. And Emma, were you able to get into this stuff on the computer? You're good? Okay, cool. All right, so make sure that edit data block is blank and then just paste your stuff in there. So I'm going to use Control V to paste. And, uh-oh, here's my data. Oh, I got a whole bunch of blank lines. That's okay. All right, so before I hit OK, don't hit OK yet. Let's just double check some stuff. I unchecked the box that says I have a first column of identifiers. I do not. It's supposed to be unchecked. That's good. Next box says check, data has a header row. Does my data have a header at the top? Yeah, it says fat. If you didn't copy the word fat, then make sure you uncheck data has a header row. Otherwise, it'll take the first number and say, oh, that's the name of this data, which is bad. Okay. All right, I'm good. Okay. And it says on the right, summary statistics. And it says my sample size is 315. Does that sound right? Yeah, that's what the study said. There should have been 315 numbers there. Cool. And it calculated the mean, the standard deviation, the minimum, Q1, the median, Q3, and the maximum. So I'm going to explain what all those numbers mean. And then we have this graph. They're giving me a dot plot. And so each dot is one of these numbers. And if two people have almost the same number, they're stacked on top of each other. This is what we call a distribution of data. When I look at this distribution of data, I see this kind of curved shape right here. And then I see a tail out to the right. So if it has a right tail, how would I describe the skew of the data? Is it right skewed or left skewed or neither? It is right skewed. Yeah, the tail is the skew. So I would say, hey, this data is skewed to the right. What does it mean to be skewed to the right? It means there were a few people who had way higher fat numbers than everybody else. That's what the skew tells me. We'll write that down in a minute. We're gonna use the pictures and numbers to describe to somebody what we discovered about the fat intake of the people in this study. All right, to do that, we need to first, on our notebooks, copy down this summary statistic table. And then I'm gonna tell you about each number in detail. So I would like you to copy down onto a piece of paper. I highly recommend this data right here. And I'm gonna cheat by doing a screenshot. No, I'm not. I'm gonna actually write it down like you guys are. Let's do that. So I'm just gonna move this over for a sec. So hopefully you have it on your screen. If you don't, it will appear on my screen in just a second. All right, come here, data. Where'd you go? There you are. Okay, so these are called summary statistics. And we have a sample size of 315. And the sample size usually gets the letter N. So I'm just going to put a little note equals N next to that. We have a mean of 77.033. And the letter the sample mean gets is an X with a bar over the top. That's the letter we use for the sample mean. Standard deviation. .829. The letter we use for standard deviation is a small lowercase s. So from now on, if you see an S in this class, you're like, oh, standard deviation. Got the minimum. Minimum doesn't get a letter. 14.4. We often abbreviate it as just MIN. In words, I'm going to write here quartile 1. And that number is 53.950. Its variable name is Q1. Median 72.9. Its variable is the letter M, lowercase. Quartile 3, 95.25. And question is, do we include those extra zeros? It's optional. That's capital Q with a little 3 next to it. Then we have the maximum. It doesn't exactly get a letter, but often we abbreviate it as max. So we talked about the mean and the median last class. The mean is when you sum the numbers and you divide by the sample size. Standard deviation is way more complicated. I will write a formula down for it. We will never, ever use the formula directly. We'll use a computer to calculate it for us, okay? The book writes down the formula somewhere in section 2.3. I'll write it down in a minute, but I just want to explain what it means in a brief statement. It is a measure of the average spread from the mean. So just a note about that. I am below average in height and weight for the average adult male in the US. I'm below average, right? My brother is a little above average in height, but he's probably right on the average weight of an American adult male. Okay, American adult male, I think the average right now is around 210 pounds, right? It's been climbing over the years. We haven't been getting taller, we've just been getting bigger. So some people are average, some people are below average, some people are above average, agreed? Yeah, and so if I'm not average, that means I deviate from average. I'm a deviant in height. I'm a deviant in weight. I'm below average in each. It's not a bad thing to be a deviant. It just means you're not average, no big deal. So standard deviation tries to measure, on average, how far is each number from the middle? Sometimes data is really spread out. Sometimes it's really tightly packed. Like sometimes when I give an exam, everybody gets an A. Whoa, that's awesome, tightly packed. Other times the scores range from like 30% up to 100%. Whoa, that's a big range. So sometimes things are spread out, sometimes they're tightly packed. Standard deviation helps try to measure that idea. I'll draw a picture of how we measure that in just a minute. But the bottom line, what you need to know is standard deviation talks about the average spread of the data from the middle being the mean, not the median. Okay, so we'll play with that in a minute. Minimum, that's pretty straightforward. I don't know what else to say about that. It's the smallest number there is in the data. Q1 is an interesting number. So think about the word quartile. It sounds like the word quarter. When I think about quarter, I think 1/4 of something, 25%. So what Q1 is, it's a line you draw in the list of the numbers to say 25% of the numbers are at or below this point. That's what Q1 is. I'm going to write that underneath here. So quartile 1 it's a number where 25% of the data values are at or below that point. "25% of the numbers are at or below that point." I'll show you a picture of that. So I'm going to go back to StatKey for a second. Where'd it go? Oh, I moved it to the other screen. That's right. There you are. I clicked on the box plot tab in StatKey. It comes with a dot plot. Then it gives me a histogram option. Cool, it draws a fast histogram. That's nice. And then we can also draw a box plot. So in the box plot here, I want you to pay attention to the box in the middle and the left edge of the box. It's a little over 50, agreed? And if we look at Q1, Q1 is a little over 50. So Q1 is the left edge of that box. There's a line down the middle of the box. That looks to me to be around 70 something. The median is 72.9. The median is that middle line of the box there. The right edge of the box looks to be around 90-ish to me, looking at the scale at the bottom. Q3 is 95.25. So that left edge of the box, that right there is Q3. So this is called a box plot or a box and whisker plot. And usually there's two ways to draw it, at least two ways to draw it. One way is to identify the minimum, identifying a number line where Q1 is, quartile 1, where the median is, where the quartile 3 is, and where the maximum is. Draw a box from Q1 to Q3, draw a line through where the median lives, and then draw whiskers out to the min and then out to the max. So my simple version of the box plot would not have these dots here. I would just draw a line all the way out to the max. StatKey cut the line short here because it's claiming that these numbers out here are unusually large compared to the rest of the numbers. I'll explain how StatKey figured that out in a minute. Okay, those are potential outliers in the data set. We talked a little about outliers last class. So the minimum Q1, median Q3, and the maximum, they are known as a 5-number summary of the data. The 5-number summary builds a box and whisker plot. Excel does not build good box and whisker plots. Google Sheets does not build good box and whisker plots, unfortunately. I write to them every year and say, please make a better one. I haven't done it yet, but StatKey makes a pretty good one here. So if I wanted to include a box and whisker plot with like a histogram in Excel, I would have to copy and paste this one into Excel or into Google Sheets or into my notes to do that. So we're going to draw this in just a minute. All right, so I mentioned what Q1 was here. Want to take a wild guess at what Q3 would mean? Yeah, the third quarter, which would be 75% of the data, is at or below that point. When I took my SATs in high school to go to college, they gave me a score, like how I did on the reading and how I did in the math. And they also gave me what's called a percentile. They said your verbal score on the SAT was in the 30th percentile. Uh-oh, what does that mean? It means 30% of, I did better than 30% of people. Unfortunately, that means 70% of people did better than me. I'm blaming it on my Rhode Island accent. I grew up in Rhode Island and we had a hard time with the letter R, like ka. I was shocked in elementary school when I discovered the word ka had an R at the end. What the heck? So quartiles and percentiles. So a quartile is specifically the end of a quarter. End of the first quarter, end of the second quarter, end of the third quarter. There's even a fourth quarter. What would the fourth quarter be as a percentage? 100%, the fourth quarter quartile would be the maximum. And guess what the median is as a quartile? 50%, which would be the second quartile. Yeah, so it turns out this 5-number summary here, let me use a different set of colors, from the min to the max, this is abbreviated as the 5-number summary. It turns out, although there's only 4 quarters in a whole, there are 5 quartiles. And a quartile is the end of a quarter or the beginning. So let's draw this out. So I am going to do a little copy and paste here with this. So I only want to look at the 5-number summary for a minute. We'll come back and do the standard deviation. New page, please. So what I'm going to do is I'm going to help you learn how to draw a box plot by hand. And I want to emphasize the difference between a quarter and a quartile. They're related, but different ideas. So step 1 is we have to see the numbers in front of us. Step 2 is we draw a number line. So I'm going to draw my best line. Fortunately, I have a line tool here. So here's my number line. Oops, I got a little crooked, but all right, I'm going to go with it. All right, so on my number line, I need to go from 14.4 all the way up to 235. So I think to do that, maybe I'm going to start here at 0, and then I'm going to jump by maybe 50s. So what if I did like 50, 100, 150, 200, 250, 300, 350, 400. And whenever, like, think back to algebra classes you took. Whenever you make a number line, the numbers have to be equally spaced. Otherwise, it's not really very meaningful. So I did my best to make sure each of these lines was the same distance apart. And I wish I had graph paper right now. All right, sometimes I do, sometimes I don't. All right, so I think I did an okay job there. Then what I'm going to do is, let's say I'm going to go underneath here because I don't leave much room. I'm just going to make some marks to estimate where each of these numbers would be on my number line. And I'll show you why I'm going to do them underneath in just a second. So that's 50, 25 would be around here. There's a different color here, 25. So I'm going to guess 14.4 is around here. And I'm just going to come down below here and make a mark at where I think 14.4 is. 53.95. Now think about the scale I have in front of me on my number line. I can kind of estimate where 53 is, but not the 0.95. So I'm just going to think of it as 54. So if this is 50 here and that's 100, 54 is probably just a little bit over here-ish maybe. So here's my 54. What's next? 72.9, let's call it 73. 50, 100, 75 is right in the middle. So I'm just a little bit to the left of the middle there. So that should be around where 73 is going to be, about there-ish. 95.2, pretty darn close to 100. Maybe it's around here-ish, right about there. And then finally the maximum, 234, 236-ish. So here's, why did I go to 400? I must have read that number as 300 accidentally before. All right, I went out way too far. Let's see, 300's there, 250's here, 235, that's 225. I don't know, what about here maybe? if that's 250. That's my best estimate on this number line. That's about right there. And then I mentioned that to do a box plot, a box and whisker plot, we need these 5 numbers, and the middle 3 numbers make the box. So then I'm going to draw my best box around Q1 to Q3 here. So it's going to make it a little bit bigger there. Let's turn this into a box. And then the median comes down through the box. And sometimes the median is going to look like it's right in the middle of the box. Sometimes it's going to be over on the edge, one edge or the other. Every data set's going to look different. We'll look at that in a sec. And then I'm just going to draw whiskers out to my other numbers. So whisker out that way and a whisker out that way. So this right here is the basic version of the box and whisker plot. So again, this number right here is my min. This number right here is Q1, little m for the median, Q3, and the max. Box and whisker plot. Not bad. Now, the StatKey version stopped short and made some dots. So I want to talk about that next. StatKey was trying to identify outliers. And I talked a little about outliers last week, but I didn't show how to measure them. StatKey is saying, starting at around 160.2 out to that 235, those numbers seem to be bigger than the rest of the numbers. They don't fit with the other group. If I look at the histogram, I see a tail to the left there. I think the tail starts after 150 or around 150. Would you guys agree? Otherwise, the other blocks, they kind of form a nice little clump, a nice little hump there. And if I look at the dot plot, again, I see a tail that seems to be after 150. They're a little farther spread out than the other side, right? It doesn't match what's happening on the other side. So here's how we do outliers with a box plot. So to identify outliers, what we do is we try to figure out how wide the box is. That's pretty straightforward. We just take whatever the number for Q3 is and subtract Q1, okay? And I can do that. I just need to take the 95.25 and subtract the 53.95. I'm going to ask my calculator about that. Let's see, 95.25 minus 53.95. And I get 41.3. When I whip out my calculator here, that's how wide the box is. So this particular one, again, is about 41.3 wide. That number has a name. It's called the interquartile range. For short, we'll call it the IQR. And it's just Q3 minus Q1. How wide is the box? Okay, so that's step 1 of identifying outliers. Step 2 is we take that IQR and we multiply it by 1.5. We basically make it 50% wider than it is. So we're going to take 1.5 times the IQR. All right, calculator says 61.95 for these numbers. Then what we do with that extended width there is we add it to Q3. So we're going to add that 1.5 times the IQR to Q3, and we're going to take it away from Q1. We're going to subtract that 1.5 times the IQR. and see where we land on our number line. So that's my step 3. I want to calculate what is Q1 minus 1.5 times the IQR. And I want to calculate what is Q3 plus 1.5 times the IQR. So I'm going to go over to my calculator and do that. So let's see, my Q1 was 53.95 minus my 61.95, and I get -8. Interesting. So that would be off my chart here. I'm just going to make a little note right there. That's somewhere over there. And then for the other one, I want to add on the 95.25 to that IQR extension. I get 157.2. All right, so on my number line here, I'm going to make a little mark. Let's see, there's 100, 200, 150. I think 157 would be around here-ish. So I'm going to translate that down to my box plot. So this is the point on my number line where I would say any number bigger than 157.2, that's unusually big compared to the majority of data. And if there's anyone that has a fat number that's below -8, they're too low compared to everybody else. Okay, I don't know how you could have negative fat, right? So we would just say, well, nobody's too low, right? They're okay, because you can't have a -8. But that's the number we calculated. Oh, well, that's the number. Does it make sense? Yes and no. I mean, the number is -8. You can't have -8 fat. So we could say, if anyone has a fat intake of 0, they would still be okay. They'd still be like in the data, in the reasonable group of data compared to everybody else. I doubt anybody takes in no fats. That's pretty hard to do. What would you eat if you had no fat? Everything has fat in it, doesn't it? Trying to think, like pasta. Pasta might not. Water, yeah, water doesn't have fat in it, but pasta, most pasta has no fat, but I don't know, I have to look at the label. Okay, so it's hard to do. Anyway, are there outliers in this data set? Yes. Are they big or small compared to everybody else? They're big, yeah. So there's a few people in the study who had grams of fat per day that were higher than the rest of the group. Okay. Sometimes there are no outliers in the data set. Sometimes there's outliers below and above. Sometimes they're just below. Every data set's different. So just to show that off for a second, let's go back to StatKey. And because we pasted our data in, and I don't want to do that again, we're just going to open a new StatKey tab. So leave this one here. To do that, what you could do is like on the title where it says StatKey here, you could open that title in a new tab, would be one option. But I want this one still there. I just want to go mess around with their data. So I'm going to go back to the one quantitative variable here. And I'm just going to look at some of their other data sets and box plots. So this one right here, that looks kind of like the one we just did, except there's only one outlier. Okay, let's pick a different data set. How about toenail arsenic? What the heck is toenail arsenic? Okay, I don't know, but let's look at it. Box plot. Okay, so this one right here, there are outliers to the right. There were a few measurements that were unusually large compared to the others. Otherwise, I'm going to scribble on this a little bit. I'm going to redraw something like this one just to talk about it. Let's go new page. So that box plot looks something like this. We had a little line and then a narrow part of the box there, a wider part of the box here. And then this side went out and then had an outlier. Was there an outlier? Yeah, there were a couple there. So their version did something like that. Reminder, what are these numbers here? So this number right here is the min. This number on a number line right there is Q1. This number right here is the median M. This one right here is Q3. And way out here is the max. And I mentioned earlier is there are 5 quartiles. But there are only 4 quarters. Okay, so a quartile is an endpoint of a quarter. The min is the 0th quartile. So I'm going to call the min is also Q0. Then there's Q1, the first quarter, the end of the first 25%. The next 25% would be 2 groups of 25% or 50%, which would be the second quartile. So the median here is also Q2. And the max we could call Q4. Because it is the end of the 4th quarter, right? 100% of the data. Max is where 100% of the data is at or below that point, right? So there's 5 quartiles, but 4 quarters. So the group of data that goes from here to there, that right there is 25% of the data. That's supposed to be a 2 there. 25% of the data lives in this region right here. Guess what lives in this box right here? 25% of the data. Each quarter marks where you stop another 25%. So in this little range right there, that's another 25%. What percent of the data lives in this box right here? Well, the end of it is the 75th percentile, but just from here to there is exactly 25% of the data. Well, actually, it's roughly 25% of the data. I say roughly because do you ever get a data set where there's exactly 100 numbers? Not usually. So what that means is the value of Q3 is actually not a number in your data. And so it's roughly 25% is in between. And guess what percent of the data lives from that point all the way out to the max? 25% again, yeah. So what can I say about this data set? Well, I can say the lower half of people's fat intake is between 14.4 and, oh, this is the other set of numbers, sorry. Toenail arsenic. The low for toenail arsenic was 0.73. The median was 0.15. So what I can say is the lower half of toenail arsenic measurements are narrowly squeezed in between 0.073 and 0.158. But the upper half of the data is widely spread out between 1.58 and 0.851, right? That's what the picture shows me here. Which quarter, not quartile, quartile is a number, a quarter is a range of numbers. Which quarter is the widest in this picture? Not the third one. The third one would be right here. It would be from here all the way to the end. Yeah, the 4th quarter, the upper 25% of measurements are very widely spread out compared to the other ones. Interesting. The middle 50% of data is moderately spread out in this box here. That would be from Q1 to Q3, so between 0.118 and 0.334. So the box tells us about how the data is spread out. It's tightly packed in the low end and widely spread in the upper end. It's the way it is. Tells a little story there. All right, how are we doing on time? We are doing excellent on time. Cool. All right, so what did we just look at? We got a little bit more work to do. We've taken a look at the 5-number summary. And the only thing really we have to talk about that's kind of new is standard deviation. I'm doing things a little out of order compared to the book because standard deviation is the harder thing to understand in my opinion. So I'm gonna take a break right now and then we'll look at what standard deviation means. And then we'll look at another data set and we'll talk about all these numbers again in their graphs. All right, let's take 5.